Welcome back. In the last three videos, we have seen that a vector function is a function um, that takes as input a real number t, and its output is a point on a curve, or you can say its output is a position vector of a point on a curve. Um, so the domain of a vector function is a set of real numbers, and the range of a vector function is a set of points on a curve, or you can say, I mean, the range you can say is a curve, um, um, and it's a curve in R2 or R3, or in fact, we can do this in any other dimension. So so now I want to introduce the concept of orientation of a curve. The orientation means a description of how the curve is traced as t progresses over the domain of the curve's vector function. So, which I'll explain more in the next example. When we express a curve, we use either this notation right here or this notation right here. Um, so, so for example, here is an example. So we have a curve C, and it is parameterized by this vector function out of t, which is equal to the vector t squared minus 2t comma t plus 1, where t varies from negative infinity to infinity. Now, instead of that notation, we could also use this notation where we write that the x coordinate of the curve is given by the function t squared minus 2t. The y coordinate of the curve is given by the formula t plus 1, and the here is the range of the parameter t. So let's now say we want to draw this curve, and we want to come up with the orientation, or we want to describe how the curve is traced as t progresses over its range. Well, one way to do it would be that it would be like a computer type of solution. That is, you calculate lots of points on the curve for different values of t, and then you plot them. So, for example, let's say you take these values of t, so -2, -1, 0, 1, 2, 3, 4, and for each of these t values, you compute the corresponding point on the curve by using the formulas for x and y here. And so if you compute those points, you get a table like this. So here I got these points. So for t equals to -2, I get this point, 8, -1. T equals to 1, I get the point -1, 2. So here's the point -1, 2. X is -1, y is 2. This is the point when t is 1. So I plot the points corresponding to each of the t values that I picked, and then I join them in a curve. Hopefully I have enough points to see the shape of the curve. But let's try to do it in a different way, let's do it analytically. That is, sometimes you might be able to eliminate the parameter t, and then come up with an equation satisfied by x and y. So then what it means is that the x and y coordinates of the curve satisfy an equation, and if it is a familiar equation, then that tells us what the curve is. So let's try to do that in this case. So in this case, we know that x is t squared minus 2t, y is t plus 1, and t is between -infinity and infinity. Now, from the formula for y, let's solve for t. And so t is y minus 1, and then substitute that in the formula for x. And if I do that, I get x is equal to y minus 1 squared minus 2y minus 1, and minus 2 times y minus 1. And so then x would be, if I expand this square, I get y squared minus 2y plus 1. Here I get minus 2y plus 2. And then if I simplify this, I get x is equal to y squared minus 4y plus 3. So notice we have eliminated the parameter t, and then we came up with an equation involving x and y, which is a familiar equation. This is a quadratic equation, so we know that the curve must be, the graph of this equation is a parabola, so the given curve is part of this parabola. And if you complete the square on the right hand side here, then you get x is equal to y minus 2 squared minus 1. From this, we know that this is a parabola that opens to the right with vertex at the point negative 1 comma 2. Now, let's be careful. So once we eliminated t and we got this familiar equation and we know it's a parabola, all we know at this point is that the curve is this curve given by this parameterization here. The curve given by this parameterization is part of the parabola, but is it the entire parabola? We don't know yet. And is it how is it traced? We don't know yet. So let's figure that out. To figure that out, we have to analyze x and y as functions of t. So from Calc 1, we know how to find where x is increasing and decreasing as a function of t, and where y is increasing and decreasing as a function of t. So if I look at x, x is t squared minus 2t, so its derivative would be 2t minus 2, or 2 times t minus 1. And the derivative would be 0 when t is 1. So when t is 1, the derivative is 0. And when t is 1, the x value would be negative 1. Now, when t is less than 1, this derivative here would be negative. So it would mean that x is decreasing on the left of t equals to 1. On the right of t equals to 1, this derivative is positive and x is increasing there. Now, as t progresses from negative infinity to 1, x is decreasing from infinity to negative 1. And the reason I know that is because when t is big and negative, t squared is big and positive, and that's the dominant term here. So we know that x is going to decrease from infinity to negative 1. Now, as t progresses from 1 to infinity, then x is increasing from negative 1 to infinity. On the other hand, when we have y is equal to t plus 1, I don't even have to analyze anything. This is, I can see that as t progresses from negative infinity to 1 and 1 to infinity, y is always increasing. So y is increasing from negative infinity to infinity. So putting this together, what we see is, this statement that I'm writing here, that is the orientation of the curve, because this is describing how the curve is traced, and also it is telling us whether the curve is the entire parabola. Why? Because let's think about it. So what we know is that as t progresses from negative infinity to 1, x is decreasing from infinity to x equals to negative 1. Right? So at t equals to 1, x is negative 1. Now, as t progresses further after 1, x is now increasing from negative 1 to infinity. Now, all along, as t progresses from negative infinity to infinity, y is always increasing. Y is increasing from negative infinity to positive infinity. So the y coordinate is moving upward. The x coordinate moves to the left, comes to negative 1, and then moves to the right again. So that tells you we get the entire parabola, and it is traced in the direction of the in the direction of the arrows. So these arrows tells us the orientation of the curve. Okay, so with that, let me stop. In the next video, we will be looking at some parameterizations of circles. Okay, see you then.